In the previous video, we talked about how a linked list is nothing more than a series of connected or linked nodes. Each one of these links to the next node in the chain. Now, if you look at this, though, we have an arrow that goes from the first node to the second node to the third node. But where does the third node point? Well, it doesn't point anywhere. It points to null. In fact, this is how we know that it is the end of the road, the end of the train. So we have names for the front and the back of every linked list. The front of a list is always called the head. The back of the list is always called the tail. The driver class, let's write this out here. If we have a driver class, it maintains one node called the head. That's all it stores. It does not even know that the other nodes exist, if they do exist. In fact, the value of head itself may in fact be null if there are no actual nodes in the list itself. Just like we can have a regular list that doesn't have any elements yet, we can have a linked list that doesn't have any elements yet. And if that's the case, that just means that the head has a value of null. Now, whenever we want to go through the data, as we stated before, we have to go through in a very specific order. We have to go from the head to the tail. We cannot jump the ship in any way because the driver class doesn't even know if there are any other nodes to go to. So this interaction is what we're going to discuss. So let's talk about when to use linked lists versus when not to use linked lists. We want to use linked lists if we want to do a lot of insertions. If we want to insert new data into the list itself. And the reason being is that it's very easy, if it's sorted data, it's very easy to get to the proper location. And all we'd have to do is create kind of a middle thing, a middle node right in between. And instead of, what we would do is we'd just change where each of these nodes point. So instead of this node pointing, instead of the first node pointing to the second node, we could make it just point up here. And then get rid of this line and have this node point down there. That's how easy an insertion is. We just kind of say point to a different location. Don't point to that next one, point to this one instead. And that one will point to the one that you used to point to. So that's how we easily insert a new node. Let's just get rid of this so we can actually see everything. Oops. Alright. So insertion. We also have the ability to do quick deletions, and it works very similar. All we'd have to do is find the one that we want to delete and have the previous one point to whatever one that one was pointing to. So if I wanted to delete this guy, I would just say you now point there. Very simple, and it's like the other one. It's like the middle one never existed. Now think about how this would actually work if you were doing this with an array or a link or a list. Insertion, not so much of a problem with a list. Deletion, not so much of a problem with a list. But if you're dealing with an array, an insertion means that you would literally have to shift every single element after where you want to insert it into, move over to the right. And the deletion would be the opposite. You'd have to shift everything over to the left. It's the exact same idea. Now, a regular list, it handles that stuff for you under the hood, at a cost, of course. And then there's sorting. Sorting is also very quick because, again, it's just the idea of manipulating where one node points to. Just quickly point to another thing. We don't actually have to move any data. We just say, hey, point somewhere else now. That's all there is to it. Again, with an array, or even a list in this case, you'd actually have to physically move things in memory and where they actually are located. Another good thing is if you don't know how many elements, because it only takes up the space required, just like a list does, it's not going to waste anything. In fact, there's no overhead at all. As opposed to a list, which has a little bit of overhead. A linked list has zero overhead. It just, you maintain the elements in memory, and that's it. Each element maintains the next element, or each node maintains the next node. If you have memory concerns, of course, this is because you only store the data that you need. So when do you not use a linked list? Well, because we have to go from the front to back to access certain individual elements, just like you do on a hard drive to access data, we don't use a linked list if we need fast access. right? And we also don't use it if we need random access. What do we mean by random access? Direct access. Remember RAM, random access memory? It really just means go directly to a certain point, not to a random point. Be very clear on that. So essentially means if you're doing a lot of reading, if you're doing a lot of reading, don't use it. All right, so reads. Sorry. Yes, if you're doing a lot of reading, don't use it. If you're doing a lot of writing, then use it. It's a very effective tool. So in what case would we actually use one? In which case when we use an array versus a linked list? Well, let's analyze the difference between arrays and a linked list. Oops. When we want to access data in an array, it runs in constant time. So for data access. Whereas a linked list runs in linear time, big O of n. Because you have to go through every single element. Linear time. Insertions and deletions for an array are run in linear time. So you have to move every single element before and after, depending whether you're doing insertions or deletions. With a linked list, you don't have to do any of that. So it actually runs in constant time, relatively speaking, for insertions and deletions. Arrays have a constant size. Not the most useful thing when you really need to deal with a lot of data and you don't know how much data. Whereas a linked list, they're infinitely scalable, so they can expand forever. So they're expandable. Your only limit is your RAM. Sorting only involves pointing to a different node. It's very easy to sort. Sorting is easy and cost effective. And that's about it. Like a list will grow and shrink with the data that it's needed, and it can actually be empty at some point. So that'd be when the driver class is holding a head that is pointing to a null value. So those are the common comparisons between arrays, lists, and linked lists. In the next video, we're going to talk about all the different functionality that a linked list actually has.